This video is on conversion problems. First, let's talk about conversion factors. A conversion factor is a ratio of equivalent measurements. It starts with two things that are the same, like 1 meter is 100 centimeters. Let's write it as an equation. 1 meter equals 100 centimeters. Next, we can divide on each side of the equation to come up with two different ways of writing the number 1. Here's what it looks like. So 1 meter equals 100 centimeters, and let's divide both sides by 100 centimeters. Of course, 100 centimeters and 100 centimeters cancels. If you divide a number by the same number, you get 1. So now this says 1 meter over 100 centimeters equals 1. Okay, but we could have done it the other way as well. We could have divided both sides by 1 meter. So 1 meter divided by 1 meter equals 100 centimeters over 1 meter. The 1 meters will cancel off and turn into 1. Now we have 100 centimeters over 1 meter equals 1. So there are conversion factors, two different conversion factors, but they both equal the same thing. They both mean 1. So a conversion factor, like I said, is a unique way of writing the number 1. In the same system, they're defined quantities, so they have an unlimited number of significant figures. So when we're doing our math here with conversion factors, you won't have to round to the correct number of significant figures because it's unlimited. An equivalent statement always has this relationship. This is really important. You should always be analyzing your conversion factors or your equivalency statements and make sure that this holds true or this makes sense. Big number, small unit equals a small number with a big unit. If you have a really big number like 1,000, you better have the smallest unit of the two. If you have a small number like 1, you better have a really big unit. For example, 1,000 is a big number, millimeters is a small unit compared to 1, which is a smaller number than 1,000, and meter, which is bigger. So it doesn't necessarily mean it's going to be right, but it has more of a chance of being right if this is correct. If you reversed it, like if you said 1 millimeter equals 1,000 meters, then your big number small unit won't equal your small number big unit. You'll have it reversed. So always try to remember that. Big number small unit equals small number big unit. All right, so let's practice writing some conversion factors for the following units between kilograms and grams. So if I have 1 kilogram, that equals 1,000 grams. Remember that prefix kilo is the only prefix that makes the number bigger. 1,000 grams in 1 kilogram. So if we divide both sides by 1,000, I could cross off the right and get 1. And my conversion factor would be 1 kilogram over 1,000 grams equals 1. Or we could have divided both sides by kilograms. 1 equals 1,000 grams over 1 kilogram. Two conversion factors that both mean 1. This could be used in a conversion problem to convert between kilograms and grams. Next, feet and inches. Why don't you pause the video and give this one a try? You probably know how many feet are in inches. Let's see if you can write two conversion factors for these units. Okay, so 1 foot equals 12 inches, of course. If we divide both sides by 12, we get 1 foot over 12 inches equals 1. Or we could have done the reverse and had 1 equals 12 inches over a foot. Okay, how about quarts and liters? Now, if they give you units like this that you're not familiar with, they have to give you the conversion factor like this. 1.096 quarts equals 1 liter. Okay, but if you know this, it should be easy to write two separate conversion factors. Okay, you just start with the equivalency statement and divide both sides by one or the other. I'll divide both sides by 1 liter. So 1 liter and 1 liter will cancel off to be 1, and we'll get 1.096 quarts over 1 liter equals 1. Or we could have done the opposite. 1 equals 1 liter over 1.96 quarts. All right, so you might be saying, Mr. W, I get the idea. Just take the numbers and divide them, and you flip them, and you can get two different ways of writing 1. So what is this good for? Well, we can multiply by the number 1, not really the number 1, but a conversion factor that means 1, creatively to change the units from one unit to the other. This is something you're going to have to do a lot in the chemistry course. Okay, let's do an example here. If I have 13 inches, how many yards is that? So you may know that there are 3 feet or 36 inches in a yard. So there's our conversion factor that we're going to use to make there's our equivalency statement, I should say, that we're going to use to make a conversion factor to convert from 13 inches to yards. So we're first going to always start with the one piece of information that they tell us in the problem, which is we have 13 inches. We want to turn that into yards. So we're going to multiply that by the conversion factor. Now we have 2 separate conversion factors we could write for this, but only one will get us the correct answer. So we want to have our units above and below cancel off. So if I have inches on the top, I want to have inches down below and yards on the top. The unit that I want to convert to is always going to be on the top of my conversion factor here. So that tells me that I should do 1 yard over 36 inches as our conversion factor. This way inches and inches will cancel off above and below and leave me with the yards. Then I need to do the math. So to do the math in a conversion factor problem like this, the rule is you always multiply by everything on the top and divide by everything on the bottom. So you'd go 13 times 1, but you don't really need to do that because anything times 1 is that number. So 13 times 1 is, of course, 13. So I can skip the step with the 1 if you want to. So I could just go 13 divided by 36 in my calculator, and that will equal 0.36 yards. Okay, so these things are called conversion factors because they allow us to convert units. But really it's just multiplying by 1 in a creative way to cross off the units I have and turn it into the units that I want. Okay, this type of math has a fancy name. It's called dimensional analysis. It's a way to analyze and solve problems by using units or dimensions for the measurement. So if we break that word down, the dimension means a unit, such as grams, liters, or centimeters. And to analyze something means to solve something. So in a way, we're using units to solve the problems. If the units of your answer are right, for example, if they cross off, like we did in our previous example, chances are you did the math right. And you just need to plug it in the calculator correctly. So dimensional analysis provides us with an alternate approach to problem solving instead of with an equation or algebra. It's important to note that there's multiple ways to get the correct answer in the type of math I'm about to show you, but I want you to go with me on this dimensional analysis process because it's going to come back a lot in this course, and it's going to be a lot more difficult in the future to solve these problems with an equation or algebra. So I really want you to try this dimensional analysis. But at the end of the day, all I really care about is you get the answer correct. But right now we're kind of using training wheels that are going to come back and be more applicable in some of the chemistry math that we do later in the year. Okay, let's do another practice question. A ruler is 12 inches long. How long is this in centimeters? Okay, they have to give you a conversion factor. If it's not on table C, they have to give you some information, unless it's really obvious, like feet and inches, something like that. Okay, so you may not know this, but you'll probably come to know this throughout this chapter. We'll be using this conversion factor a lot, but 1 inch equals 2.54 centimeters. So again, we always want to start with the number they give us, which is 12 inches. And then we want to set up a bracket. I like to set up the bracket and then think about what units I want above and below on this bracket so that my units will cancel off above and below and turn into the units that I want. So there's 2 possible conversion factors that we can use, but we want inches on the bottom. So I'm going to put 1 inch on the bottom and 2.54 centimeters on the top. Now that inches are the same above and below, they can cancel. I'm left with centimeters on top, which is what the problem's asking for, so I know it's time to punch it into my calculator. So remember, all we do is multiply by everything on the top and divide by everything on the bottom. So 12 times 2.54 and then divided by 1. But whatever that number is, if I divide it by 1, it's not going to change. So just like we skipped multiplying by the number 1, we can also skip dividing by the number 1. So in your calculator, all you need to do is 12 times 2.54, enter, and you will get 30.48 centimeters. All right, what if they asked you how long is this in meters? Now you could start with your answer from the first problem and do a conversion factor from there, or we could start from the beginning. We can pretend this is a whole new problem. We'll start from the beginning and say 12 inches, and I want to convert that into meters. But I don't know the conversion factor to go from inches to meters. But I do know the conversion factor to go from inches to centimeters, because they gave that to us in the problem. 1 inch is 2.54 centimeters. But now that I've crossed off inch and inch, I'm into the metric system. And using our prefixes, we can get from one unit of the metric system to any other, because we know it's based on the units of 10. And we have table C to help us. But we need to do another step, so we need to add another bracket. All right, so I have centimeters on top, which means I want centimeters on the bottom, and I want meters on top. So then I just need to know the relationship between centimeters and meters. And in 1 meter, I have 100 centimeters. Remember our relationship? Small number, 1 is a small number. Meter is a bigger unit than centimeters. Big number, 100 is big. Centimeters, centi is small. It means hundredth. Okay, so now centimeters and centimeters cross off. And I'm left with meters, which is what the question's asking. So it's time to punch it into my calculator. So I get my calculator and I type in 12.0 times 2.54 divided by 100 all at once. You don't need to hit enter in between the steps. You can do this all at once. And remember, you can skip the ones. So 12 times 2.54 divided by 100 is equal to 0.3048 centimeters. Okay, next practice problem, like you do, pause the video and see if you can do this one on your own. A race is 10 kilometers long. How far is this in miles if 1 mile is 1,760 yards and 1 meter is 1.094 yards? Remember, always start with what they give you, 10.0 kilometers. Go ahead and give this a try. Okay, so let's set up a conversion factor to cross off kilometers and turn it into something else. So I don't have a conversion factor from kilometers, but a really good strategy is to get out of whatever unit they give you and get it to the base unit of your measurement, which is length here. So I want to get rid of kilometers and turn it into meters, because I have a conversion factor here to go from meters to yards, and then once I'm in yards, I can get to miles. Okay, so let's set up our bracket, put kilometers on the bottom and meters on the top, and ask ourselves, what's the relationship? In 1 kilometer, I have 1,000 meters. Remember, kilo is big, so small number, bigger unit, bigger number, 1,000, smaller unit, meters. Okay, now that I'm into meters, well, these cross off. Now that I'm into meters, I can do my next bracket. My next step will convert from meters to yards. So if I have meters on top of my bracket here, I want to have meters on the bottom, so it will cancel off. So I'll put 1 meter on the bottom and 1.094 yards on the top, right from the given in the problem. Now meters and meters cross off and go away. I'm into yards. And then you can see I need one more step to get from yards to miles, and I'll just use the given in the problem. Yards on the bottom, miles on the top. 1 mile is equal to 1,760 yards. Now yards and yards cross off. I'm left with miles, which is what the question's asking, and now it's time to go to my calculator. So I type in 10.0 times 1,000 times 1.094 divided by 1,760 yards. And that is equal to about 6.2 miles. Okay. So remember, conversion factor is a ratio of equivalent values, two numbers that mean the same thing. They're going to have different units, but those units, when compared to one another, are the same thing. We can use a conversion factor in the process of dimensional analysis to solve problems where we have to convert from one unit to another. Like I said, this is something that you will have to do a lot in chemistry. The key to doing these problems well is to write your units all the time and cross off as you go. If you keep your math work really nice and neat and straight on the paper, and you always write your units and you always cross off, and you're always asking yourself, does this conversion factor make sense? Big number, small unit, small number, big unit. You'll make a lot less errors. This is something that takes a lot of practice. So if you're struggling with it right now, that's okay. We're going to practice this a lot in class. This is something in chemistry that will not go away. We will be doing conversion problems throughout the entire course, and it will actually get a little more complicated as we go.